our focus is still on simplifying individual radicals before we move on to multiplying, dividing, adding them. But now we have some variables. We have variables underneath the radical sign here. We're asked to simplify the square root of 20x to the fourth power. So I'm going to begin by using the same factor rule that we learned in our previous lesson. I'm just going to break this up into its numeric component and its variable component, because I know how to do the first part. Square root of 20, we're looking for perfect square factors. So let's go root 4, root 5. Remember, if you put your perfect square first, it stays in the correct format where the simplified or factored out number goes in front of any radical term. So I know that root 4 is 2 and root 5 stays. Now to complete this problem, think about the square root of x to the fourth power. Is there a variable term multiplied by itself that would give me x to the fourth power? If you're thinking of x squared, you would be correct. If I had x squared times x squared, that would give me x to the fourth. That's our exponent rule with the same base. Add your exponents. So I can't leave my answer like this, and this re-emphasizes the point that the radical component of the answer goes last. So the correct way to write this answer is 2x squared root 5. They're all multiplied by each other, but that's the correct way to write it. 2x squared root 5. So let's talk more about what we do when we see variables. And you may want to pause this at some point just to look at my notes here, but let me narrate for a little bit over it. So every variable term that has an even degree exponent is a perfect square. So look at my example starting on the left here. The square root of x squared is x. The square root of x to the fourth is x squared. So on and so forth. The square root of x to the sixth power is x cubed, and it keeps going, all right? So if you've got an even exponent underneath a radical sign attached to a variable, you can simplify it by just cutting that exponent in half. If I had the square root of x to the 64th power, that would then simplify to x to the 32nd power. I just divide the exponent by 2. Now it's a little trickier when you have an odd exponent. So look at the example of square root of x cubed. So I need to take out a perfect square factor. We're always going to be able to do this because we know that the even exponents are all perfect squares. So factors of x cubed would be x squared and x. Since the square root of x squared is just regular x, I put that first, and I do have to leave almost like a remainder of square root x that has to stay under the radical sign. Another example here with square root of x to the 7th, we're going to take the square root of x to the 6th and leave square root of x. That becomes x cubed root x. So notice what I'm doing here. The perfect square factor you want to take out is always going to be one less than that odd number. So if I had the square root of x to the 13th power, let's say, the perfect square factor you would want to use is the square root of x to the 12th and root x. Let's do a couple examples. So one pretty similar to the one I started the video with. Let's break this into two parts. Let's break it into root 32 and root x to the 5th. So note that it's an odd exponent. Root 32, let's think perfect square factors. 4, definitely. Can we do one better? Not 9, but 16 is the best perfect square factor you'd want to use here. So check your list before you rush ahead. Root 16 is 4. Root 2's got to stay. Now let's do root x to the 5th. Like I said, with an odd exponent, let's take a perfect square factor that's one less. So I'm going to do root x to the 4th and root x. Remember, that's x to the first power technically, right? So when you multiply 4, x to the 4th and x to the 1st, you get x to the 5th. Square root of x to the 4th, like we had in our original example, becomes regular x squared, no radical sign now, and we got to keep root x. So let's put this in the correct and simplest radical form. Everything that's not under a radical sign goes first. And we know that a coefficient goes before a variable, so we'll put 4x squared. And then let's combine these two radicals underneath one sign. I've got 2 and I've got x. It's going to be radical 2x. Pause if you need to. Last example, this just has two variables in it. No additional tricks here, but you'll see how to do it with if there's two variables involved. So let's break it into 3 parts this time. Let's do the numeric part. Let's do m's, and let's do n's. Root 75, run through your list. 4, no. 9, no. 16, no. 25, bingo. Root 25, root 3, 5 root 3. We'll come back to that. M to the 9th. So odd exponent, the perfect square factor's got to be m to the 8th and root m. Simplify this, it's m to the 4th. Root m's got to stay. Square root of n to the 8th. That is a perfect square. So that's going to simplify all the way down to just n to the 4th. So I've got 3 parts here. I want to make sure I write these in the appropriate order. So simplified, outside the radical, I've got 5, m to the 4th, n to the 4th. And then left under the radical, I have a root 3, I have a root m. I'll write it like this. We are done. So break it down into parts, take your time, show your work. It is essential for these radical problems to show your work. It is very easy to make simple mistakes by trying to rush ahead or not showing all of your work.